In this session, we will see about the conversion of number system. That is, conversion between different number system. For example, conversion from decimal number to binary number, or from binary to decimal number, or from hexadecimal to binary, and vice versa, etc. So, we will see the conversion between these two number systems. So, if you are not familiar with the number systems, go and watch the video about the number system. So, before going to the conversion, we have to understand some of the basic concepts. So, the first one is the position, and the second one is weight. So, we will see what are these terms. So, for that, consider a number 1298.6134. 1298.6134. It can be a decimal number or a hexadecimal number. So, consider this is a decimal number. It cannot be an octal number because there is 9 and 8. An octal number system will not contain 8 and 9. It contains only the symbols from 0 to 7. So, this can be a decimal number or hexadecimal number. So, consider this number and suppose this is a decimal number, that is to the base 10. That means this is a decimal number. If it is a hexadecimal number, it will be written as to the base 16 because hexadecimal number have 16 symbols. If a number system is binary, that means if it is 1101, then it will be written as to the base 2, and this indicates, this subscript 2 indicates this number is a binary number. So, if it is not mentioned, this 2 is not mentioned, this number can be binary or it can be decimal, isn't it? This is 1101. It can be a decimal number, it can be an octal number, also it can be a hexadecimal number. So, we have to mention the base, then only we can identify this number belongs to which number system. So, it can be binary, decimal, octal or hexadecimal. If it is an octal number system, we will write it as to the base 8. So, 78, this is a number. If I write to the base 16, this means 78 is hexadecimal number. If I write 110 to the base 10, that means 110 is a decimal number. If I write 01 to the base 2, that means 01 is a binary number. So, there is also another way for mentioning the base. For example, consider a number 100. If it is a binary number, usually we write 2, the base 2. Otherwise, we can also write it as b, either small b or capital B. 100 to the base b means it is a binary number, and 100 to the base d means it is a decimal number. 100 to the base o means it is an octal number. 100 to the base h means it is hexadecimal. So this is how we identify a number, whether it belongs to a binary, a decimal, an octal, or hexadecimal. So here I haven't marked any subscript. Suppose it is a decimal number. Suppose, so, or I will write it as to the base 10. Consider the number 1298.6134 to the base 10. That means it is a decimal number. So now we have to see two times, the position and weight. You all know about the position. So this is the integer part. This is the integer part, and this is the fractional part. Fraction. So for the integer part, the position starts from 0. This is the 0th position. That is 8 is in 0th position. 9 is in first position. 2 is in second position. 3 is in second position, and the position will increase as we move to left. So for the integer part, the position start from 0 and it will go on increasing if we go to the left. Now for the fractional part, the position starts from -1. So for the fractional part, so this is same for the case of any type of number system. Not only the case of decimal, in the case of binary, hexadecimal, octal, the same position applies there also. So for the fractional part, the position start from -1, then -2, -3, -4, and it go on decreasing while moving to the right. So now we will see what is a weight. So let me clear this. Okay. Now we will see what is a weight. Weight is nothing but it can be represented as base raised to position. Base raised to position. Base raised to position is the weight. So what is the weight of this number? 8. What is the weight of 8? So this is a decimal number system. For decimal number system, what is the base? We have learned in the previous video. For decimal number system, the base is 10 because there are 10 symbols. For decimal number system, there are 10 symbols. So the base is 10. So base is 10, and for weight, it is represented as base raised to position. So we have found the base for decimal. The base is 10. And what is the position of this 8? The position of the 8 is 0. So 10 raised to 0 is the weight of 8. Now find the weight of 9. Find the weight of 9. What's the weight of 9? Base raised to position. Base is 10. 10 raised to 1. Then what about this 2? That is 10 raised to 2. What about this 1? 10 raised to 3. Okay. This is same the case of all other number system also. Now we will see the fractional part. What is the base? 10. What is the position of this 6? -1. So 10 raised to -1 is the weight of 6. What about the weight of 1? 10 raised to -2. 10 raised to, next is 10 raised to -3, and for the 4 the weight is 10 raised to -4. So this is how we write the position and weight for a number. So if this number was a hexadecimal number, so we will see So if this is a hexadecimal number, then there will be a small change in the respective weights. We will see how it will work. So suppose it is to the base 16. That means it is a hexadecimal number. So what will be the weight of this 8? What will be the weight of this 8? Base raised to position. What is the base? 16, because it is hexadecimal number. So 16 raised to position of 8 is 0. And for the 9, the weight is 16 raised to 1. And for 2, the position is 2 and the base is 16. So 16 raised to 2. And for this one, the base is 16 and the position is 3. 16 raised to 3. Coming to the fractional part, for the number 6, the base is 16. Base is always 16 for a number because this is a hexadecimal number. It is given in the question. So 16 raised to position is minus 1. So the next number 16 raised to minus 2, then 16 raised to minus 3, then 16 raised to minus 4. So this is how we will find the weights of a number. So this is the case. This is same for the case of octal and binary also. Only thing is the base changes. For octal, it will be 8 raised to position. For binary, it will be 2 raised to position. So we will move to the conversion. First, we will see binary to decimal conversion. So first, we will see binary to decimal conversion. So first, we will take a binary number. For example, we will take 1101 to the base 2. So we have to write from here onwards, we have to write the base. Otherwise, we cannot distinguish between the number system. So we will consider 1101 to the base 2. That means this is a binary number. We have to convert it to its corresponding decimal number, that is to the base 10. So this is what we have to do. So what is the method? So what is the technique? So method is very simple. First write the binary number, that is 1101. Now write the weights of each bit. Now write the weights of each bit. So suppose this is the given binary number. And we have to write the weight now. So just now we have learned how to write the weight. Weight is nothing but base raised to position. Base raised to position. So what is the weight of this one? Base raised to position. This is binary number. So the base is 2 and the position of this one is 0, 0th position. So position. So if you are not clear with the position, I will write the position for you. So starting from 0, and it will go on increasing if you move towards the left. So fractional part, it will start at minus 1. Before 0, it is minus 1, minus 2, minus 3. For fractional part, it will go like that. So this is the weight of this 1. What is the weight of this 0? 2 raised to 1. And for the next number, 2 raised to 2. And finally, 2 raised to 3. So now, how to get the corresponding decimal number? So to get the corresponding decimal number, what we have to do is multiply the bit with its corresponding weight. Means multiply each number by its corresponding weight and add the result. So multiply each number by its corresponding weight and add the result. So multiply each number by its corresponding weight and add the result. So we will write it. We will write here. First, this one. That means 1 into. What is the weight of this one? 2 raised to 0. Weight of this one is 2 raised to 0. That means 1 into 2 raised to 0. Now, plus second number is 0 into. What is the weight of 0? 2 raised to 1. Plus third number is 1. 1 into what is the weight? 2 raised to 2. 2 raised to 2. Plus and finally this one. 1 into what is the weight? 2 raised to 3. So this is equal to what is 2 raised to 0? 1. So 1 plus 0 into something is 0 plus 1 into 2 raised to 2. 2 raised to 2 is 4. 4 into 1 is 4. Plus 2 raised to 3 is 8. 8 into 1 is 8. So the answer is, you will get 4 plus 8, 12. 12 plus 1, 13. So 1101. So this is the question. 1101 to the base 2 is equal to 13 in decimal. That means 13 to the base 10. So this is the final answer. So this is the technique of converting binary to decimal. Here you can avoid this multiplication. You can avoid this multiplication. So that means you just need to multiply where 1 is present in the given binary number. You can avoid the multiplication of weight with the 0, because 0 into weight is always 0. So just multiply the 1 with the corresponding weights and add the result. Just multiply the 1 in the given binary number with the corresponding weights and add the result. So that's enough. That's if it is a big binary number and it contains many zero, then we can simply do by multiplying the ones with its corresponding weight and add the result. So this is quite simple step, simple method to convert binary to decimal. So now we will see the fractional part also. Okay, so we will see another example. That means I will give you another example. Convert 1000 dot 101. No need of bracket and all. So this is the base 2. So convert this to decimal. So this is the binary number. Convert this to decimal. So first we will write the given binary number. That means 1000 dot 101. Okay, now we will write the weight of the number. So this is the given binary. This is the given binary number. Now we will write the weight of the binary number. So we will first write the integer part. So this is, we will also write the position. If you are not thorough about it, I will write the position once again. So this is position 0. This is the integer part, position 0, 1, 2 and 3. For fractional part, it starts from -1, -2, -3. So now we will write the weights for this 0. The base is 2, 2 raised to 0. This is binary number, so the base is 0. Base raised to position is the weight. This is 2 raised to 1, 2 raised to 2, 2 raised to 3. And for the fractional part, the weight is 2 raised to position is -1, 2 raised to -2, and 2 raised to -3. So how to find the decimal number? Multiply the bit with its weight. Multiply the number, binary number, with its weight and add the result. And another thing we have to, I also told that we don't want to multiply where there is 0, because 0 into weight is always 0. So just multiply the ones with its corresponding weight. So we will start from the left side. So first 1 is there, 1 multiplied by 2 raised to 3 plus, then we all have zeros, we don't want to multiply that. Anyway, I will simply write it 0 into 2 raised to 2. This is the second case, and for the next case it is 0 into 2 raised to 1 plus 0 into 2 raised to 0. And then there is a decimal point, isn't it? Dot. There is a dot, so I will put the dot. 1 into 2 raised to -1. So this 1 into 2 raised to -1 plus 0 into 2 raised to -2 plus 1 into 2 raised to -3. So simplify this, we will get the answer. So this is equal to, what is 1 into 2 raised to 3? 2 raised to 3 is 8. 8 into 1 is 8. 8 plus, this is 0, this is 0. So we can actually strike it. This is 0, this is 0, this is 0. So that is 8. Dot. Then it comes dot. 8 plus 0 plus 0 plus 0 is 8. Dot. So now we will see the fractional part. So the fractional part, it is 1 into 2 raised to -1 plus 0 into 2 raised to -2 plus 1 into 2 raised to -3. So I will use a calculator. So first 1 into 2 raised to -1. 2 raised to -1 is 1 by 2. That is 0.5. So 1 into 0.5 plus, so second time I am cancelling because 0 into 2 raised to -2 is 0. And the third term is 1 into 2 raised to -3. What is 2 raised to -3? 1 by 2 raised to 3. That is 1 by 8. So 1 into 2 raised to -3 is 2 raised to -3. So 2 raised to -3 is 1 divided by 2 raised to 3. 2 raised to -3 is 1 divided by 2 raised to 3. That is 1 divided by 8. That is 1 divided by 8. So the answer is 0.125. So the answer is 0.125. So the final answer is 8.125. So therefore the given question is this: 1000.101 to the base 2 is equal to 8.125 to the base 10. 8.125 to the base 10. So now you can try with your own different examples to convert binary to decimal. So now we have seen the conversion of binary to decimal. So we have to check the other conversions also. That means conversion of octal to decimal, and also the conversion of hexadecimal to decimal. So we will see these two conversions in the next video.